Hi everyone, we're looking at challenge 5 from the new Little Book of Algorithms version 2.0, and we'll also look at challenge 6 as well. We're essentially tracing if statements and looking at how they might work. To start with, this idea of tracing if statements or doing dry runs is something which is very common as a programming exercise, both in the GCSE exam, the A-level exam, and also at university as well. Essentially, you're asked to think about what will be output when this program is run, and we'll just check this out and see how it works. So we've got this mystery number procedure which takes num as a parameter. The number is less than 5, we're printing 8. If the number is 5, we print 5. L, if the number is 3, we're going to print 1, and else we print num. So when we run 8, it should output 8 because 8 is not less than 5, is not equal to 5, and is not equal to 3, so it goes to here as 8. Number 3. So if we have a look at this, now 3 is not equal to 5. Well, it's not it is less than 5. So actually, it might print 8. But here you've got another if statement which says, well, if it's equal to 3, then print 1. So which one is it going to do? Let's check the code. You might think it prints this one because it runs first. You might think, actually, it might get overwritten and it might print 1. So let's run it. So here, if we enter 3, it actually prints 8. So what has happened there then is it's just run into this because it's less than 5. It never even reaches this if statement. So we can carry on with this. And so 2 is also less than 5, so it's going to print 8. And then 5 is equal to 5, so it's going to print 5. Yeah? Now, if we have a look at that, maybe we should have this as 12. I think I'll change the example to 12. So if we enter 12, it's not 5. It's not less than 5, it's not equal to 5, it's not equal to 3. So therefore, when 12 is run, it should output 12. Let's check that. Yes, that works. It says in the program above, 4 lines of code are redundant. You can remove them without affecting the program. So we already know that this line is somewhat redundant because actually, if it's 3, then this is already run anyway. It's going to output 8, so that is redundant. We also notice if the number is equal to 5, we print 5. But here, the else already says that if the number is not less than 5, we just print the number back out itself. So this line is also redundant as well. Yeah, so that is what you would be left with. So to conclude then, effectively lines 4, 5, 6, and 7 could theoretically be removed in order to get exactly the same output. So 4 to 7. So 4, 5, 6, 7. Yeah. Lines 6 and 7 say that when the number 3 is passed in, the output should be 1. However, this does not work. Explain why. Well, it's because that already falls into this if statement here. So this one never even happens. Yeah? So the first if statement. Is executed. And third branch, i.e. num equals 3, is never reached. Okay. You're then asked to rewrite the program so that it does output 1 if the value of the number is 3. So if we go back to our mystery program then, so if we want this to happen before this, then all we need to do is this becomes our elif, and this becomes our if, and we move that to the top. So we'll cut that, and we'll paste that here. Ideally, you'd use tab. do that. So hopefully now when we enter number 3, it'll output 1. If it's less than 5, it'll output 8. If it's 5, it's going to output 5, so we can get rid of that because actually that's not necessary, and we'll just output this instead. So what this should show is that if we input 3 now, instead of saying 8 as it said here, it's going to output 1. Okay, so those are challenges 5 and 6 on the Little Book of Algorithms 2.0. Challenges 7 and 8 I think we'll cover in a separate video.